Hi, good morning to all. Today we are going to another important sessions from the chapter complexes and protein binding. So this sessions mainly deals with the introduction to complexes. So here we are going to study in detail about what are complexes, and we are going to understand the significance of complexations in pharmaceutical products, and we are going to appreciate the fundamental forces that are related to the formation of drug complexes. And there are different types of complexes, so we are going to differentiate between the different types of complex mechanisms of complex formations, and also we are going to understand the mechanism of coordinate bond formation leading to the formation of coordinate complexes. So what are complexes? So A and B are the individual components. They react together to form complex C, and the property of complex C will vary from both A and B. So in other words, they are the separate class of compounds which results from the interaction among different chemical species. Say for example, A stands for the drug and B stands for the complexing agents. A and B react together to form complex C. Okay, so A and B are the separate class of compounds. They react together to form new chemical entities that we call it as C or complexes, and property of C will vary from both A and B. So complexes possess some properties which are different from those of its individual components. So in this previous example, A and B are the individual components. They react together to form complex C. The properties of complex C will vary from both A and B. So there are various intermolecular forces are involved in the formation of complexes. Okay, so the various intermolecular forces involved in the formation of complexes are they are covalent bond, coordinate bond, van der Waals force, ion dipole, 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 induced dipoles, and final one is hydrogen bonding. What do you mean by dipole? See, dipole are nothing but two equal and opposite charges separated by a unit distance, that is known as electric dipole. Okay, so the certain molecule has a tendency to induce dipole in another molecule. Such molecules are known as induced dipoles. So the dipole and dipole interaction will be there, ion and dipole interaction will be there, and also in dipole and induced dipole interaction will be there. So certain molecules has a tendency to induce dipole in another molecules, that is known as the induced dipoles. So interaction between dipole and induced dipoles are also responsible for the formation of complexes. So these are the various intermolecular forces involved in the formation of complexes. Next ones, complexes can also formed from a donor acceptor mechanisms. So here one can act as a donor and another one is can act as an electron acceptors. Okay, so for example, in the previous example, A reacts to the A to react together with B, forming complex C. Here A is act as a donor and B is act as an acceptor. So A donor acceptor react together to form complex C. Okay, so here the donor means which has a tendency to donate electron pair, that is known as donor. So donor is usually a non-metallic atom or ion. It is not a metal ion, it is usually a non-metallic atoms or ions which has a tendency to donate electron pairs, that is known as donors. An acceptor is usually a metallic ion which has a tendency to accept the electron pair, that is known as acceptors. So a complex formation, we can say it in other words, it is an interaction between donor and acceptors, interaction between donor and acceptors. Okay, so metal ion is act as a electron acceptors and non-metallic ion will act as an electron donor. Donor means which donates electron pairs. Acceptor means which has a tendency to accept the electron pair is known as acceptors. Next ones, This same phenomena or this same mechanism can be explained on the basis of Lewis acid base reactions. The same mechanisms. Okay, so according to Lewis acid base reactions, a non-metal atom and non-metallic ion and metal ion. Non-metallic atom can act as an electron donor and metal ion will act as electron acceptors. So any non-metallic atom or ion, whether it is free or contained in a neutral molecule or an ionic compound that can donate the electron pair, can act as a serve as a donors. So the same phenomena can be explained on the basis of the Lewis acid base reactions. One can act as a donor, another one can act as an acceptor. So interaction between Lewis acid and Lewis base reactions lead to the formation of complexes C. Okay. Now, so this can be, so interaction between A and B can be explained in the basis of electron donor and electron acceptors. So metal ion, non-metal ions, and or in other ways it is interaction between Lewis acid and Lewis base. Okay. Now, I already told you that there are various intermolecular forces are involved in the formation of complexes. So, the various intermolecular forces between A and B or in between A interaction between donor and acceptor can be any one of these forces. Okay. So, the first one is the van der Waals forces between forces of dispersions. I already told you that the interaction between dipoles and interaction between induced dipoles and dipolar types. And also the hydrogen bonding is also provides a significant force in some of the molecular compounds that we will going to study in detail in coming slides. And also there will be an interaction between a donor and acceptor by establishing a coordinate bond is also is an intermolecular forces between the components A and B. So the coordinate bond is mainly seen in the metal complexes. So there will be a coordinated sphere and ionization sphere. So in that coordinated coordination number is another important factor, that is the number of molecule that can be donate the electron pair or that can bound with the central metal ion is known as the coordination number. So there are different types of complexes like metal ion complexes or organic molecular complexes or inclusion complexes. The mechanism behind the formation of each class of complexes is entirely different from each other. Okay, so there may be an interaction between dipole and induced dipole interactions, or there may be a chance of van der Waals force of dispersions in metal complexes like coordinate establishing a coordinate linkage between the component A and C. So these are the various types of interaction that is possible between the component A and B. Okay. So the complexes can be classified mainly into three types. One is metal complexes, organic molecular complexes, and another one is inclusion complexes. Inclusion complexes are also called as occlusion complexes. They are also created based on the interaction between host molecule and guest molecules. Okay, so here the one molecule will act as a guest molecule, and another molecule will act as a host molecules. So their interaction will be different compared to metal complexes. In metal complexes, the interaction is mainly by establishing the coordinate linkage between the component A and B. Okay, so as discussed in the previous classes, there may be different mechanisms for the different class of complexes. So this is the end of these sessions. Thank you for your active participation. Thank you all. We'll continue with a new topic. Thank you all.